In this segment, we're going to talk about why distributed computing is an attractive option when processing large-scale datasets, and we'll also provide a brief overview of Apache Spark. So let's consider the problem of performing a statistical analysis on a massive dataset. To do this, our first thought might be to try to use a traditional tool, something like MATLAB, R, or Excel, and to run it on a single machine. The problem is that we need more hardware both to store and process these large datasets. So what can we do? Well, one option is to scale up. And in other words, to use one large machine to process this data. So for instance, instead of using our laptop or a desktop, we can use a machine with many more cores or more main memory. This can be an attractive option for medium scale problems. However, there are issues with this approach. First, these larger machines typically involve specialized hardware, which makes them expensive and also limited in terms of their availability. Second, this isn't truly a scalable option, in the sense that no matter how large one single machine is, eventually the data is going to be large enough that that single machine can't support the data. So eventually we are going to hit a wall. So what can we do instead? Scaling out is another option, and the idea here is to work with many small machines and to connect them together over a network in a distributed setting. This is an attractive alternative in the sense that it clearly scales to massive problems, as that we can easily add additional nodes to our network. Moreover, each node of our network, or each of these machines, typically is commodity hardware, something like your laptop or your desktop. And as a result, each node is cheap and both readily accessible. There are, of course, issues associated with working in a distributed setting. So the first is that each of these machines is connected via a network. And now we need to deal with network communication as these different machines need to talk to each other. And network communication can be a real bottleneck in a distributed setting. Second, there's added software complexity when programming in a distributed setting, or in other words, to coordinate the actions of all of these different nodes. Spark, as a general open source cluster computing engine, is designed to simplify this process of programming in the distributed setting. Spark is what we'll be using for our course exercises, and it has many attractive properties in the context of large-scale machine learning. First, it's particularly well suited for machine learning, both in the sense that it provides fast iterative computations and efficient communication primitives. Second, it's simple and expressive, providing APIs in Scala, Java, Python, and R, as well as an interactive shell for exploratory analysis. And in our course, we'll be focusing on the Python API. And finally, Spark comes packaged with higher-level libraries, which can be useful when constructing machine learning pipelines. And these higher-level libraries include GraphX for graph processing, Spark SQL for SQL processing, Spark Streaming for working with streams of data, and MLlib, which is Spark's in-house machine learning library, which we'll talk more about throughout this course.